Welcome back to Backspace Academy. Elastic Beanstalk, it's one of AWS's deployment services, and it allows you to deploy your applications to complex architectures on AWS. And it does this without you having to worry about the underlying architecture that is behind that. Elastic Beanstalk, it looks after everything for you, and you just need to worry about writing your code. We'll also talk about how Elastic Beanstalk can create highly available and fault-tolerant architectures and what that actually means. And then finally, we'll look at the different deployment options that are available on Elastic Beanstalk. Elastic Beanstalk, it's been around for quite some time, was first launched in 2011. It allows you to quickly deploy and manage applications on environments, and those environments are launched for you without you having to worry about how it all works. It'll automatically handle capacity provisioning. It'll launch a load balancer for you if you need that. It'll auto scale for you, and it can also implement health monitoring so that if one of these instances that are launched becomes unhealthy, it can replace those automatically for you. If you need to change your code after you've deployed it, it's quite easy to upload new versions of that code. And that can be done through the console or the command line interface. And also complete environments can also be redeployed if need be. Your application that you're deploying could be a Docker container. It could be raw code. It could be Node.js, Java, .NET, PHP, Ruby, Python, or Go. You just supply your code and Elastic Beanstalk will deploy that for you, and it will provision that Node.js or whatever environment for you automatically. Or it could be a service such as Apache, Nginx, Passenger, or IIS. The Elastic Beanstalk process, it starts with us going through an application creation process where we will first off upload a version of our software or our code or whatever it is. And then Elastic Beanstalk will launch an environment, and that will consist of EC2 instances, or it could be a single EC2 instance. It could be a multi-AZ environment, but we define that for Elastic Beanstalk, and it will do that automatically for us. From there, we will have our environment launched and our code will be running on that environment. Now, if we find that we need to deploy a new version of that code, we can deploy that to that existing environment, or we can create a whole new environment. It doesn't really matter. So if we deployed it to our existing environment, then when that environment has gone through that update process and the new version is deployed and running, then the environment will feed back to the application to notify that that new version of your application is actually running. One of the big advantages of Elastic Beanstalk is that it can create a highly available and fault-tolerant architecture without us having to worry about how to actually do that. So what is a highly available and fault-tolerant architecture? So here we've got the AWS cloud, and as we know, it's divided up into regions, and those regions are divided up into availability zones. So if we have our architecture distributed across multiple availability zones, if one of those availability zones goes down, our infrastructure will still continue to operate and serve requests. Now, our virtual private cloud, that will span the entire region. So it will span multiple availability zones. And so what we can do is that we can launch instances into both of those availability zones. And that's going to give us high availability if one of those availability zones goes down. Now, in order for our architecture to respond to spikes in demand or increases in demand because an availability zone goes down, what we can do is we can launch our instances using an auto-scaling group. So if demand on one of those or a group of instances increases, the auto-scaling group will add instances to accommodate that. And vice versa. If the demand goes down, we will reduce our number of EC2 instances. And that allows for elasticity in our design. And finally, to receive requests from the outside world and to distribute those requests to those multiple instances, we're going to need an elastic load balancer to do that. And that will also have the advantage of conducting health checks on our instances so that if communication breaks down between the elastic load balancer and our EC2 instance, then our auto scaling group will automatically add additional instances, and that creates fault tolerance in our architecture. Just the same as you've got a number of options available for architecture that you're deploying to, such as a single EC2 instance or a highly available and fault-tolerant architecture across multiple availability zones, you've also got a number of different deployment options that you can use. So for example, if you've got 20 EC2 instances, an all-at-once deployment will deploy that across all of those 20 EC2 instances all at once. The downside of that is going to be that while that is occurring, your architecture won't be able to respond to requests. So that's obviously not a good thing. So another option there is to do a rolling deployment, and that will deploy your application to a single batch at a time. So what that means is that if you've got 20 EC2 instances, it can deploy that to, say, 2 at a time. So you're not going to be down by much. You're just going to be down from 20 instances down to 18 instances, but your architecture will still be responding to requests. You can also do a rolling with an additional batch. So what that will do is that if you've got, again, 20 EC2 instances, it will temporarily increase to 22 while you're doing those 2 deployments across those 2 EC2 instances. And that way you're still going to have your capacity at 20, which is what you have designed for. The other option there is an immutable deployment, and that is a bit of a variation of the all-at-once. So it's still doing an all-at-once deployment across your 20 EC2 instances, but while that's going on, it's going to deploy another 20 EC2 instances. So temporarily, you're going to have 40 EC2 instances. So it's going to double up a lot on your capacity. But through that period where your environment is being deployed, or your new version or whatever is being deployed to that environment, you're not going to be suffering any downtime. And finally, we've got blue-green deployments, and they will have 2 environments that will be running your application under the one Elastic Beanstalk application. And so what that is you will have a blue environment and a green environment. One of those could be a development environment, and the other one could be your production environment. So when you get to the stage where your development environment is ready to go to be deployed, to deploy that, all you simply need to do is to switch over from one environment to the other environment. And then your old environment will then become your new development environment. And so that is very straightforward with Elastic Beanstalk, because what it does, it will simply allow you to switch the domain names for those 2 environments automatically for you. And so that makes sure that your changeover doesn't involve any downtime for returning of requests. Later on in the course, we're going to learn a lot more about blue-green deployments and how to deploy those across Elastic Beanstalk. But coming up next, we're going to use Elastic Beanstalk to deploy a highly available and fault-tolerant architecture. So make sure that you download the lab notes for this one, and I'll see you in the lab.